Unit 7, Day 2, the slope formula. So today we'll start right away with an example. Example 1, determine the slope between the points 7, 6 and 3, 2. So in order to find this slope, let's first start by graphing the points. So let's graph 7 and 6. So we'll go 7 on the x-axis, 1, 2, 3, 4, 5, 6, 7, and 6 on the y-axis. So there's our point, 7, 6. Okay, and now we just need to graph our second point, 3, 2. So we'll go on the x-axis 3, and we'll go on the y-axis 2. And now let's just draw a line between them so we can create this line. Okay, now to calculate the slope, let's draw our rate triangle. So our rate triangle is as such. We know that the rise is going up 1, 2, 3, 4, and we know that the run is going to the right 1, 2, 3, 4. And again, we know it should be a positive slope because the line is going up and to the right. So that's from the earlier lesson. If it was negative, it would be going down and to the right. So therefore, our slope using our rate triangle is equal to rise over run, which is equal to 4 over 4 and is equal to 1. So our slope between the 2 points is 1. Next, we're going to investigate if there's a way to calculate slope without using the rate triangle. So to get you guys thinking about how we can maybe do this, there's a few things I want to point out. To determine the slope algebraically, so without this rate triangle method, notice that the rise equals 4 is actually equal to the difference in the y coordinates. So if we were to take 6 minus 2, we get a rise of 4. Likewise, through the rate triangle we found our run was 4, but that's also equivalent to the difference in the x coordinates, so 7 minus 3. So now that we have investigated that pattern, here's the new way to calculate slope. So therefore, the formula for calculating slope with numbers, so without the rate triangle, is as follows. Slope is still equal to rise over run, but now we can calculate rise, the difference in the y coordinates over the difference in the x coordinates. So you want to take, if we have 2 points, x1, y1, and our second point is x2, y2, you take the second y coordinate and you subtract the first y coordinate from it, and then you divide it by the second x coordinate minus the first x coordinate, and that's how you can calculate slope now. So to verify that this algebraic method works the exact same way as that rate triangle, let's do this second example. So determine the slope between these 2 points, first using a rate triangle, and second using the slope formula. And you'll see we get the exact same answer. So let's first do the rate triangle. Let's graph our points, -4 and 2, and +2 and -2. And let's connect the dots to create the line. And now let's draw our rate triangle. First of all, I want you guys to notice that this line is going down and to the right, so it should be a negative slope. So our rise is going to be 1, 2, 3, 4. And our run is going to be -1, 2, 3, 4, 5, 6. Therefore, using our rate triangle method, slope is equal to rise over run. And as we found on the graph, our rise was 4 and our run was -6, and that can be reduced to -2 over 3. Let's now try this using our slope formula. So slope is equal to rise over run. We know our rise is delta y over delta x, so the difference in the y values over the difference of the x values. So y2 minus y1 over x2 minus x1. So our y2 coordinate is this -2 minus our y1, which is +2, and our x2 is +2, minus our x1, which is negative 4. So we're left with negative 2 minus 2 is negative 4 over 6, which again is equal to negative 2 over 3, which is the exact same answer. So therefore, both these methods do work for calculating slope. Example 2, calculate the slope between the following points using the slope formula. So our slope formula is delta y over delta x, which is equal to y2 minus y1 over x2 minus x1. So here's our y2 minus our y1. So 8 minus negative 4, and our x2 is 5, and our x1 is negative 3, so 5 minus negative 3, which is equal to 12 over 8, and can be reduced to 6 over 4, and that can be reduced to 3 over 2, which is our final slope. For part B, it says calculate the slope between these 2 points. I want you guys to take note that these 2 points are the exact same ones in the example above, only they're reversed. So the 5, 8 is now written first instead of second. So let's see if we can come up with a pattern that you guys notice after solving this. So it is equal to delta y over delta x, which is equal to y2 minus y1 over x2 minus x1. y2 is negative 4, y1 is 8, x2 is negative 3, x1 is 5. Negative 4 minus 8 is negative 12, negative 3 minus 5 is negative 8. Negative over negative is just a positive, so we're left with 12 over 8. Now we can start reducing, so that goes down to 6 over 4. And finally 3 over 2. And let's see. Notice it's the same as the slope we calculated above. Based on our results in that example, we can conclude the following about the slope formula. The order of points does not matter. Either point can be your x1, y1 or your x2, y2, as long as you designate them beforehand and plug them into the formula appropriately.